get to it. Okay, hello everybody and welcome to Coffee with Chloe. Actually, no coffee with Chloe in the afternoon. So I'm going to be going and continuing through the Cryptography Engineering textbook. It's a textbook written around, a little over 10 years ago, going through efficient cryptography engineering and like practical examples and applications. It's been pretty fun to go through so far. I did find a better textbook for this. So currently I have this textbook on the right. I cannot copy and paste. I've been having to type out everything myself, which has been great, but I am happy, very happy to say that if I go to my drive, which I could have just went to it from here, I guess, although it says I'm logged out, which is a little annoying. Oops, that's not it. There we go. So if I do this and I go to my papers, I will see that this is the, I think it's this one. Probably. Oh yeah, I can already tell. See? I can highlight things. So I'm going to download this onto my computer. I am going to open it. Gosh, that was not what I wanted to do. I wanted to open it into files, downloads. There we are. Open with document finder. That's what I want. Now I should be able to, oh, this is so much better. So previously all I had was this randomness. I'm gonna close this. I don't want that ever again, because now I have everything I could possibly want. So for some reason it doesn't seem, I think because I have this open, so I have chapters now. I can actually come through, go to part 2 where I'm at, go to chapter 3, oh my gosh, and get straight to where I'm trying to get to. This is super cool. I love this so far. We're at two fish, or not two fish, serpent. Oh, which one? Serpent or two fish? Can't remember which one we're currently at. Let's close this and see, we're at two fish. Wonderful. So I'm going to close this, and maybe now it'll let me. It does not want to let me. Very sad times. It doesn't. Let's see if this is still working. It is still working. Wonderful. So I'm just gonna get this this does not like me. There we go. And then let's see how far we can bring this over before we get any issues. Okay. Zoom in quite a bit. Let's go full width. Okay, this is looking pretty good so far, I think, this new setup. I can see what's on the right-hand side, I can take my notes easily on the left-hand side, and let's start talking about two fish. I got about an hour and 7 minutes before I'm going to try and wind down and start taking my notes for week 3. So week 0 was the intro, week 1 was the survey, and week 3 we're actually getting started with the project. And so let's get started. So Two Fish was an AES finalist as well. It can be seen as a compromise between AES and Serpent. So it can be seen as a compromise, and I'm still going to type it out for the most part, between AES and Serpent. So I want to start using tags. I've talked about this already, potentially, to be able to start linking between my documents. Maybe it's not too big of a deal. So for now, I'll try and leave things out. It's nearly as fast as AES, but has a larger security margin. Let's just put that up here. Nearly as fast AES, but larger security margin. Okay, the best attack we know of is on 8 of the 16 rounds. So best known attack is on 8 of 16 rounds. And I'm going to put a star. I think that's what I was doing. I think I actually changed what I was doing. Oh, I was using a tag. I was going to practice using my tags here. Just tag edit. Again, for me, tag edit for now doesn't mean anything except for, is that still the case? Like, I don't know if it's still only 8 out of 16 rounds. Maybe it's more rounds now. Maybe it's not even secure anymore. This book is old. I would have to check. So I'm not doing that right now. Each time I go through this, I'm just taking notes for now. I'll go through this stuff later, and someone else can let me know if this is a algorithm that's already been taken out. I'm trying to get through the notes today. So the biggest disadvantage of Toothfish is that it can be rather expensive to change the encryption key, as Toothfish is best implemented with a lot of pre-computation on the key. So you do a lot of pre-computation, you get a certain key, and so it's a bit, it's almost as fast, but I guess finding a new key, you have to do all this pre-computation again. So this seems to be the biggest issue. So biggest disadvantage is the biggest disadvantage is that it can be expensive to change the encryption key. Excuse me, because there is a lot of pre-computation on the keys in Toothfish. Add that. Simple enough, I suppose. So Toothfish uses the same feastal structure as DES. Okay, so that's good to know. We're using feastal again. So uses same structure as DES. So the encryption function and the decryption function are the same. They're just backwards of each other. That's one of the properties of a feastal, I suppose. An overview is given in figure 3.3. We saw that already. Toothfish splits the... Okay, this is what I want to try and remember. It splits the... Okay, so... Splits the 128-bit plain text into 4 32-bit values. And most operations are on 32-bit values. Okay, you can see the feistal structure of Toothfish with f being the round function. The round function consists of 2 copies of the g function, a function called the pht, and a key addition. The result of the f function is XORed to the right half, the 2 vertical lines on the right. The boxes with those symbols in them denote rotations of the 32-bit value by the specified number of bit positions. Oh, okay. I was like, what are you talking about? Now I understand what it's. I'm like, it's right here. Again, I always like when they show you the diagram first, and then they give you an explanation. So I'm going to read through this and then copy and paste the diagram, and then I think I have to actually convert these, but I'll get there and then we'll talk about it. The S boxes are somewhat different in contrast to all the other block ciphers we've seen in this book. Okay, so these are different than all other block ciphers apparently in this book. Well, so far, these block ciphers are not constant. Okay. Rather, contents depend on the key. Maybe this is what we're talking about, like some of the pre-computation as well, potentially. there is an algorithm that computes the S tables from the key material. The motivation for this design is that key-dependent S boxes are much harder for the attacker to analyze. This is also why two-fish implementations often do few computations for each key. They pre-compute the S boxes and store the result in memory. The PHT function mixes the two results of the G functions using 32-bit addition operations. The last part of the F function is where the key material is added. Note that addition is shown as anyways, and exclusive OR as so this is addition and exclusive OR. The last part of the function is where the key material is added. So this is different. This is just adding, I guess. I gotta go through this again. But Twofish also uses whitening at both the start and the end of the cipher. Additional key material is added to the data. This makes the cipher harder to attack for most types of attacks and costs very little. At both the start and end of cipher, additional key material is added to the data. And costs very little. Because I guess it costs little, I think, because you're just adding key material. So you're just doing an addition, and you already have the data there. Okay. As with the other ciphers, Twofish has a key schedule to derive the round keys and the two additional keys at the start and the end of the actual cipher key. The two additional keys at the start and the end from the actual... I know, okay, but like, I'm not even gonna lie. I don't even know what you're talking about there, my guy. There's a reason why this figure is so much larger and detailed than the others. Two of us were on Twofish Designer team, so we could lift this figure straight from our Twofish book. So they're talking about where? This figure is more larger and detailed, so I should definitely dig into this one. Okay. So let's get a screenshot of this, and let's copy it and save it and paste it, and then that was pretty much the end of it. So I do want to write more of these notes because I feel like I'm gonna... Where are we? Okay, so we know it uses the same Feistel structure as DS. This is the image. And then as you watch the image, hopefully we'll try and understand it as we go down. So, you have P, which is the plain text, the message. Okay. So you're going to split the 128-bit plain text, right, into 4 23 32-bit values. So you have K1, K2, K3, K4. What? I think it says 4. I can't even see it. Do I have to like zoom in here? Why can't I see what that says? 125. Oh, K0. That's funny. Yeah, I can't see. I'm gonna keep it zoomed in a bit more just because. There we go. I'm blind. Okay. Split it into those values. So to me, would have been helpful to be like, these values are k 0 to 3, right? That was probably the most important part of this, at least for me. I'm not very good at math, but math does help me remember things. Why are you being a butt? Oh, I gotta do that. Can I do this? I always think I can, but no. And then no. Can never remember how to do like the brackets in like the base, but that's good enough for now. So you have K0 to K3, these 32-bit input, these 32-bit values. You could see the first structure of two fish, with f being the round function. So you have f here. This is a round that happens, right, over and over and over again. So del structure can be seen with f being the round function. So hopefully that was clear from before. So this is a round. The round consists of 2 copies of the g function. So it's a bit different than normal. So around here, round consists of 2 copies of the g function. Okay. A function called PHT and a key addition. So you have 2 copies of the g function, a function called the PHT, and a key addition. So I think the idea is that you're adding the keys K2R plus, it's too small for me to see. So you have these S boxes, you have the MD. Okay, let's keep going. The result of the F function is XORed. So this is a XOR, not an addition. Okay, yeah, these are the additions. And you do some funky swapping. Interesting. And this is plus 8, plus 9. Interesting. Okay. The right half, the 2 vertical lines on the right. Yeah, that seems fine enough. You take the left side as inputs. You do all this stuff with this in the function. You do this little G thing. You do all this MDS. You do S boxes. You do this PHT function stuff. Yada, 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 whatever. You do some additions. And then when you do your additions, you're going to XOR them with these 32-bit inputs. But, oh, because this breaks things up? The boxes with these denote rotations of the 32-bit value by the specified number of bit positions. So you're going to rotate by 8, rotate by 1. I'm not sure. Okay, so you rotate bit positions. Maybe here I'm not understanding because I'm seeing you're doing these. You bring them in. Oh, they get split. They come back out together. You add, you do addition here. So I guess you get back to a 32-bit value. You do multiplication, you get another 32-bit value. You do some more flipping, and then you go through again. Right? You don't get 128 bits. You go back to 32 bits, 32 bits. You do more 32 bits, and at the end, you get the whitening. Okay, makes sense. Oh, and now it's gonna. Okay, I'm so excited. So we do an addition. The result of the f function is XORed into the right half, and the two vertical lines on the right. Yeah, that's simple enough. The boxes with those symbols denote. That was pretty complicated, so I'm just gonna copy and paste that one. Like, that's not something else. And I want to see if it creates. Oh, it didn't create little beautiful things for me. It just used. Whoops. Okay. I mean, that's just like a note, I guess. Each G function consists of 4 S boxes, followed by. Okay, so a round consists of 2 copies of the G function. I gotta start highlighting better here so I can read. Each G function consists of 4 X boxes, so each consists of 4 S boxes. Followed by a linear mixing function that is very similar to the AES mixing. Okay. Followed by a linear mixing function. So MDS is a linear mixing function. Similar to AES mixing. Okay, the S boxes are somewhat different. In contrast to all the other ciphers in this book, these X boxes are not constant. These S boxes are not constant, but contents depend on the key. There's an algorithm that computes it. The motivation is that the key-dependent S boxes are much harder for the attacker to analyze. Okay. This is also why two-first implementations do pre-computations. They pre-compute S boxes and store the result in memory. Whatever, that's like chill. The PHP function mixes the 2 results of the G functions using 32-bit addition operations. Right, PHP. That's simple enough. The last part of the F functions where the key material is added. The last part of the F function is where the key material is added. That makes sense. Key addition. The last part of the F function is the last part of the F function. Keep it simple. Okay, I think that's it for Two Fish. And then there's the other AES finalists, which I'm not sure there's anything to even write much about here, but we'll read it through. We have discussed 3 of the 5 AES finalists in some detail. There were 2 more, RC6 and Mars. RC6 is an interesting design that uses 32-bit multiplications in the cipher. During the AES competition, the best attack broke a 17-round version of RC6 compared to 20 rounds of the full RC6. So, I mean, that's quite a few. I mean, I don't know. Sounds like a few rounds to me. Mars is a design with a non-uniform structure. It uses a large number of different operations and is therefore more expensive to implement than the other AES finalists. Both RC6 and Mars were selected as AES finalists for a reason. They are both probably good blocks. I like that. Probably good block ciphers. Details about their internal operations are in their respective specifications. So yeah, I'm just gonna go like 3.5.5 other AES finalists. What is, that looks ugly. Okay, that's why. And then I'm just gonna literally say like 3 of 5 did, 3 out of 5 already discussed. RC6 and Mars as well. And if I really cared, I would link these on Wikipedia. I'm not going to read about these. Just not anytime soon, at least. So 3.5. There's just so much newer stuff that I'm so excited about reading that just doesn't. I'm sure one day I'll end up reading it, but which block cipher should I choose? Okay. The recent cryptanalytic. I say the word too fast, but before I've actually read it. I see this part, I just say the word. Cryptanalytic, which is what I said, but I still want to read it. Also, I never learned this. Anyways. And the recent cryptanalytic advances against AES make this a tough choice. Despite these cryptanalytic advances, AES is still what we recommend. It is fast. It's so interesting. All known attacks are theoretical, not practical. So, okay. So, recent attacks make AES a tough choice. Still recommend AES, which I think is just funny. Block. It is fast. That seems to be just like literally what people are saying. It's fast, it's secure enough. Also, yes, attacks are theoretical, not practical. Sure. Although, again, I think that's like an edit. These days, I think attacks have gotten better. But, okay, even though AES is now broken academically, these breaks do not imply a significant security degradation of real systems practice. It is also the official standard, sanctioned by the U.S. government, and everybody else is using it. They used to say nobody gets fired for buying an IBM. Similarly, nobody will fire for using AES. AES has other advantages. It is relatively easy to use and implement. I've actually done AES, I think, once. It seemed really straightforward. Relatively easy to use and implement. That seems like something actually useful to me. Wow, we need to zoom in again for sure. It's going to make me go crazy. All cryptography libraries support it, and customers like it because it is the standard. There are probably circumstances in which 3DES still is the best solution. If you have to be backward compatible or are locked into a 64-bit block size by other parts of the system, then 3DES is still your best choice. However, keep in mind that triple DES has some unique properties that cause it to not satisfy our security criteria, and be especially careful with the small 64-bit block size. If you are really concerned about future cryptanalytic advances, you could always double encrypt. First with AES, and then with you could always double encrypt. First with AES, then Serpent or two fish. And like obviously in today's time, that would mean, you could double encrypt with two different schemes that are maybe, Groth 16 and I don't even know. I don't know many up to date. I feel like when I was learning this stuff a couple years ago, it was all way too much for me, and now I actually understand it, like 1%, and I'm like, oh my gosh, I understood nothing before. But anyways, let's continue. If you do this, remember to use different independent keys for each block cipher. If this is done, remember to use different independent keys for each block cipher. Independent. I am going to add the dictionary and add dictionary. Okay. Or use AES with an increased number of rounds. That's pretty interesting too. AES could also be used then increased number of rounds. That's pretty cool. Like 16 rounds, 20 rounds, 28 rounds. So yeah, you can just keep increasing the key size and just keep doing more rounds. Very interesting. So I guess the reason you have to do more rounds is because the keys are getting bigger, I assume. And so maybe I'll do this as a note, like 28 rounds for 256-bit keys. That might be a fun little, I don't know. I say fun little project, but when will I ever get to something like that? Anyways, further, remember that the recent cryptanalytic advances against AES are only just coming out as we finalize this book. It is too early to tell exactly how the community will respond. Keep an eye out for a general consensus or shift in the direction from the community. Perhaps NIST will issue some specific recommendations for how to address the recent discoveries against AES. If NIST makes recommendations on how to respond to new attacks against AES, or if there is a clear shift in the consensus of the community, no one will fault you for following those recommendations or that shift. We also need to return to one of the other issue with AES. We haven't talked much about side channel or timing attacks yet. We'll talk about these in section 8.5 and 15.3. It turns out that even though there are no known practical attacks against the mathematics of AES, no known attacks against the mathematics of AES, but it is possible to implement poorly. I think it's just more about like crypto in general, but I think the idea there, for example, and I think this is the idea, is like just getting one example of how you can do poor crypto engineering. But you can implement AES such that the time it takes to perform an operation depends on its input. Can be implemented so that the time it takes to perform an operation is dependent on inputs. Okay. On some inputs, it will take more time. Other inputs take less time. If an attacker can measure the time, a system. If an attacker can measure this time, she might be able to learn bits of the key. They might be able to learn bits of the key. If you use AES, you should be careful to use a constant time implementation or to otherwise conceal the timing information from an attacker. Use constant time implementation or somehow otherwise conceal the timing information. So I guess there could be other crafty ways to conceal timing information, but that's something to think about. Timing attacks in general. And we'll get the timing attacks apparently later on. So what key size should I use? Okay. 3.5.7. It's a long chapter. I've been doing this chapter for days now. All of the AES finalists, and hence AES, support keys of 128, 192, and 256 bits. For almost all applications, a 128-bit security level is enough. Okay. However, to achieve 120 bits of security, we suggest keys longer than 128 bits. Ooh, I like that. To achieve 128 bits of security. Simple enough. Because your key's got to be at least as long. A 128-bit key would be great, except for one problem: collision attacks. Time and time again, we find systems that can be attacked, at least theoretically, if not practically, by a birthday attack or a meet-in-the-middle attack. We know these attacks exist. Sometimes designers just ignore them, and sometimes they think they are safe, but somebody finds a new, clever way of using them. Most block cipher modes allow meet-in-the-middle attacks of some form. We've all had enough of this race, so here's our recommendation. So here you go. We're getting into the actual recommendation now. For a security level of N bits, every cryptographic value should be at least 2n bits long. So hopefully that's simple enough. So make it twice as many bits. Okay? If you want that much security. Following this recommendation makes any type of collision attack useless, because if you double it, you say, hey, we're not actually going to get 256, we're actually only getting 128, but we have keys that are twice the size. Following this, in real life, it is hard to keep strictly to this rule. For 128-bit security, we really want to use a block cipher with a block size of 156 bits, so 128-bit security use block cipher with a 256-bit block size. Okay. Sorry, apparently my grandma's eating very well today, so. Anyways, back to things. Okay, it's hard to do. Okay, but all the common block ciphers. Okay, but all common bits. Okay, this is more serious than it sounds. There are quite a number of collision attacks on block cipher modes, which we will learn about later. Still, at least we can use the large keys that all AES candidate block ciphers support, which is so interesting. So it's like they're saying you need to use block sizes. Okay? So all cryptographic values, all of them. And then we go at, or I want to be like this, or whatever. At least we can use the large keys, therefore use larger keys. Well, we're not saying that 128-bit keys are insecure per se. We're saying that the 256-bit keys provide a better safety margin, assuming that the block cipher is secure. So larger key provides a better safety margin, assuming that the block's cipher is secure. Note that we advocate the use of 256-bit keys for systems with a design strength of 128 bits. In other words, these systems are designed to withstand attackers that can perform 1 to 28-bit operations in their attack. Just remember to use the design strength 128 bits, not the key length 256 bits, for sizing the rest of the system. Yeah, makes sense. Sure, that's simple, I guess. Like, that part makes sense. Finally, let's come to the recent cryptanalytic results against AES. These results show that AES with 192 and 256 bits keys are not secure. What? Okay, so now you're saying, okay, let's just keep going. Moreover, the attacks against AES with 192 and 256-bit keys exploit weaknesses in the AES key schedule algorithm. Okay. Now, AES with 192 and 256-bit keys are not secure. I've already read this, but I always find it funny. It's always like, yeah, this book's, I think, quite funny. The authors are quite comical. Moreover, they exploit weaknesses. I'm just going to be like exploit, or they attacks exploit weaknesses in the key schedule algo. This is why the known attacks against AES with 256-bit keys are more efficient than the attacks with AES with 192-bit keys. This is also why we don't yet know of attacks against AES with 128-bit keys. Oh gosh. Okay, so no known attacks against AES with 128-bit keys. I don't know if that's still the same, so I'm gonna write edit, because I don't know if that's true still. So while in general we'd prefer a block cipher with 256-bit keys over a block cipher with 128-bit keys, assuming the block cipher is secure, the situation is a bit murkier for AES. To emphasize our desire for 128-bit keys of security, and thus our quest for a secure block cipher with 256-bit keys, we will use AES with 256-bit keys. Okay, but once there is a clear consensus of how to respond to the new cryptographic results against AES, we will likely replace AES with another block cipher with 256-bit keys. So they're even saying this is not theoretically secure, but they're going to use it because whatever. And they do use AES for like some of the examples here, which is pretty interesting. Finally, okay, so this took quite a darn while, but we're going to do it. Okay. Here. Oh. Chapter 4. I think I just wrote CH4. I can't even remember anymore in my notes. I always forget. CH3 dot. Okay. Trying to keep some consistency, you know. So CH4 block cipher modes. Okay, I am officially tired. I have about 20 minutes left. I am going to quickly take start my weekly notes. So let's open the navigation. Let's close the images. Let's go to weekly updates. Open a new note. Rename it. Week 2. Project start. I gotta stop putting so many spaces in all of this. But too much of a pain. I can't use 2 words, so maybe commence, or like, so intro. What should I call my week 2 thing? It should be like weekly updates, intro, survey. Maybe they don't all need titles, like, gosh. That's a better idea. Oh, gosh. Maybe? I don't like using spaces because on GitHub it looks ugly. But maybe I'll just do it week 2. Let's keep it like that for now. I think usually I do like my title. So week 2 is like project start. I don't really want to get as down into the weeds, so like, I guess I should give it a little example first, but like, jeez. So week 0 was very like, okay, set up the project, who am I, what are my goals, what are my plans, what's happening every day. Week 1, a little less of this kind of intro, but I had this huge kind of Actually, it was pretty long. Shoot, of this breakdown. A lot less of that. I'm literally just gonna start into the project now, just taking the notes. So settled on a weekly routine. So, Monday to Friday, like 8 to 5, pretty much is like the timeline it's covered. It's, 7:30 to 5. Maybe I should just put like 1700. Okay. So I think honestly, I'm just gonna write the weekly routine and then write what I actually do in a week. I have a tweet actually, a tweet thread. I don't know if Twitter's gonna open on this page. Probably not. Pain in my butt. Okay. Here. Twitter. Okay. What? Tweet deleted by author. It's talking about how much I love that. Here you go. I have a whole link out here, and I think I'm literally just going to link to my tweet in my, at least here, right? Why does it always do this? Pretty sure this just works. Yeah, all the other tracking info, so annoying. Anyways, so there's that one. And then I do want to kind of write it out. So So Monday, Wednesday, Friday, and then I'll just break it up into Tuesday, Thursday. And I think I'm just gonna do like AM, like PM, AM, whoops, AM, PM, whoops, and so Monday, Wednesday, Friday, AM, to keep it as simple as, that's the wrong dot, simple as possible. This is the text. It's gonna be posted somewhere, better soon on Obsidian, but for now, that's what I'm doing in the mornings. I'm taking notes here. In the PMs, again, just trying to keep it really simple. Monday, Wednesday, Friday, I'm going through the Coursera crypto. So this is not, I don't feel like looking for it. So it should just be, there you go. Okay. So PM, going through this. There's kind of notes on each, but that's not the point. The point is to kind of have a highlight here, and then basics, like the details of each day will be elsewhere. Eventually I'll have a better kind of outline of this, but for now, like the links here should get more efficient, like being on Upcloak. In the PM, instead of auditing this course, I'd hopefully be going through, like actually digging through the example, like the homework examples from the crypto engineering text For now, though, this is what it is. Tuesday, Thursdays in the mornings. Okay, so Rust, programming. There's like a textbook that Pandu, Decentricity, showed me today, which was like basically learning Rust through programming 2D games, and I was like, this is so perfect in every way. And so what I'm thinking about doing is something like that, maybe in the mornings. I do usually it would be like Rust and then math, trying to kind of cater my days appropriately. So let's see. So like generally like papers, I have a reading list that I'm going through. So maybe like reading list. So, you know, yeah, I guess like whether it would be like there's so much on the reading list. So Tuesday, Thursday in the PM we have the EPF reading list. Here we go. I have to update there's just so much. Like there's so much on the list. Yeah, so there's the reading list. There's also on like week 1 at the end of the day, I made like week 0, I had a long list of resources to go through over the weekend. I didn't touch these. So like, I mean, I touched some of them. I went through quite a few of them actually, but there's just so much stuff. So there is the reading list. Okay. Other than that, there's a lot of general YouTube stuff, but a lot of it honestly is in the reading list. So that's kind of where I'm at for the afternoons. And in the mornings, actually, I guess the mornings should be the reading list. Realistically, I would... okay. Rust programming in the mornings, Tuesday, Thursdays. There's always something new that I want to go through, and I do have a GitHub repo for crypto engineering stuff that I want to start working on. I haven't even touched it really, so let's see. Where are we? Repositories, crypto engineering. Yeah, and this isn't even like proper. It's all messed up. I think I have to like fix this. Maybe we can delete this whole repo. I think I have to delete the repo. And maybe I'll try and set up the repo today, although it doesn't matter. I'm going to Antigua, and I'm going to be doing it all like from my laptop. So it won't matter too much. So tomorrow I might stream myself. There was this is my own video. Sorry, 1 second. YouTube. Why didn't I just do it here? There's a video that I was enjoying. Your channel. No, I want to go to my library. Where is it? It was... I watched too many things. Watch later? No, it was in my history. Oh, I gotta finish this Groth 16 video. Oh, watch later. I can't forget these things. There was like a fun calendar programming thing. Yeah. Was it this one? I don't think it was. It's always hard to find. It was like a fun little. This might have been it. Yeah, it was like a fun little. Oh no, this wasn't it. No, there was like a calculator one, I thought. Oh gosh, can never understand stuff. Oh, this was the Replit thing. I don't know. Maybe I don't have something I want to go through yet. Oh, you know what I should do? For now? Oh, I'm so silly. Tuesday, Thursdays, for Rust programming, I mean, for now, until I find this book that Dicentricity is going to send me, I should just focus on, where are we? Not, yeah, research, EP. Oh, where am I going? No, not EP. F. Oh, I had a different project. Oh, I'm like remembering so much stuff. This is the one though. I need to change the title of this right now. Actually, this link is not going to work forever. Actually, maybe I'll change this right now. This is going to bother me. So I have the link here, but this name is just too long. So 0 to prod. That was fine, but we don't need all of this. I do like having the dates. And then like, or let's just, that's annoying. So just the title, I guess. 0 to prod. And Rust. I think I can't even remember anymore what it's called, but I started doing like the very beginnings of this barely, and so maybe I could start going through this textbook. It is more front end stuff, not my like. Honestly, maybe I'll just try and find the book I'm actually looking for. So, learn Rust by building 2D games. There you go. This is the book.
Flappy Bird game.
Okay. I don't know, like. Okay. Prerequisites. A running computer, text editor, video card. Okay. Cool. This is... Okay, it's on Amazon here as well. Same book. Okay, perfect. So this is the book that I think I want to go through. 2021. It's not bad. Looks like a lot of fun, actually. And there's a little YouTube video that seems to go through something similar. So until I buy the book, maybe tomorrow I'll start with like this video.
Hello. I don't have a routine. I feel pressured now. This might be the most boring talk. I hope it's not, but I at least don't have a routine. I also don't have any entertaining gifts, unfortunately. Thank you.
Okay, cool. So maybe so then I like doing this as well because like I know what I want to do. Like this is the notes I was taking more for web development. I'm kind of thinking I don't want to start on that too quickly. I kind of want to have fun with Rust a bit first. So like game dev and like I mean like obviously I'm just gonna keep it actually more general. This is just for trying to have fun with it, honestly. I should just honestly just write Rust because it's not even, it's just Rust. I don't have a specific for that yet. And so, whoops. And then I'm trying to go into like what actually happened each day. So I've already said that Tuesday I want to go through this YouTube video. And I usually like having like a reason, like what is it first. So, you know, Rust for gaming. This is like a fun little thing to go through. And now I know, okay, well, I'm supposed to do Rust in the morning, so I'll do Rust for gaming and just go through that for fun. And then I have something from the reading list that I can kind of choose from. And what I already know I want to go through actually tomorrow, if possible, would be this one. So if I was able, it would be wonderful to actually start off the morning doing a live stream of that, then have some fun with Rust for gaming. And then I have to fly out, so I might not do much else tomorrow. I fly Wednesday morning, so maybe, you know, like Wednesday travel, you know, like, and we'll see what else I do. Maybe on the plane. Actually, I want to do some stuff on the plane. So like Coursera for sure. I can download those and take them on the plane with me. So that's like almost probably number one, actually. I might just finish Coursera on the plane. That's actually probably like the best thing to do. Download as much of the Coursera content as I can on like my tablet or something, and then just like crush it or something like that. Okay, that sounds good. Just Coursera all day. I can't take notes or anything like that. So Wednesday Coursera, and then maybe like Thursday, I would definitely want to get into like that. Either I mean I'll try and find that textbook. So Rust gaming 2D text. Gotta handle that textbook. And that's probably something that would take me all day. I'd be in Antigua. I have a lot of other things to do. When it comes to Monday, I should be saying what I already did. So today was pretty busy. So finished chapter 3 notes of, you know, crypto engineering text. So the good thing about this is that notes, books, some of these things are going to bother me. Crypto engineering, and then I should be able to go down to chapter 3 and get a link for it. Oh yeah, that's already there. And then I should be able to finish chapter 3 notes. go. It's kind of all I did. You know, set up week 2 outline. I do have this kind of project section, like project idea notes, graph the model, starting persona skill set. Honestly, I think all I have time for right now is going to like uncloak.com. I can't even spell. Ugh. What did they... Let me look at the Discord first. Ah, my bad. Oh, cool! There's an interactive graph already. So we're going to have our topic, cryptography. Oh, this is so cool. And then from here, you can kind of learn more. So maybe you want to learn about cryptography engineering. And then from here, you know, there's this textbook, which, you know, hopefully will have other nodes attached that will hopefully be somewhat related to the notes that we're taking. Maybe. You know? I don't know. I think it would be really cool to also have like answers to some of the questions. But yeah, I'm getting ahead of myself again. I always get really excited when I see this. So uncloak.org. And that is, I mean, I don't even know how to, but for now, just uncloak, product ideas notes, graph model. Maybe I should have specifically, what happens if I just do that? Yeah, it doesn't work. You have to have the whole thing. So maybe I'll just do both. Like put that there and then put that there, or like that maybe. I don't even know. Anyways, this is what I have so far. Week 2, I'm not even titling them anymore. I'm just kind of going into the weeks. Calling it Project Start. I think I usually put the date. Oh, I have not been putting the date. That's kind of annoying, but that's okay. Um, 07 project start 07/11 2022. Okay. I think I do want to have like calendar dates for each one. So 10, whoops, 31, 22, I think that's correct. And then I think this one is, what day is it today? Monday, 24. So 24, 10, 22. Okay, this should be good to go. And even in like these crypto engineering notes. Okay, let's see. Do 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 do. So yeah, I'm starting to fill it with project doc, and I have week 2 notes kind of going. Finished chapter 3 notes of C text. Okay, and they're all gonna have the same. I need to commit more often, but I just do all the stuff and then commit once, and then they all have the same. You know. Okay. Perf. And I don't have multiple people committing to the same thing, to the same branch. But if there were multiple people committing to the same project, whoops. I don't know why I use master and main. I should I think it's funny that master is my dev branch. But yeah. And again, only one contributor. Eventually, there will hopefully be multiple contributors. Potentially, who knows, but not right now. And it's after 5, so delete branch. And we now have our wonderful chapter 3 completed, which is exciting. So, on that note, toodaloo, all of you. See you all tomorrow morning, hopefully, God's willing, for a stream going over. Actually, you know what? I'm going to open it up so that I don't forget, because I will forget. So QAP. This isn't even the right browser to be opening this in. Why do I have... this even open? Like, why do I even care? Oh, I was doing something here. Yeah, delete that. Let's use this one. So we're gonna go through this. We're gonna take notes. We're gonna close some of this other crap. So I guess I'll just... I might not even... Actually, I'll probably take notes, to be honest, because I want to remember it.
Quadratic
you
arithmetic
even
programs
listen to it,
from 0 to hero.
which is
There has been a lot of
insane to
interest
me.
lately in the technology behind
Meme's
ZK
pretty
snarks,
awesome.
and
Let's stop that. Like,
people
this
are
thing go
increasingly
away
trying
now.
to...
No. Yeah, there we go. So I'm gonna go through this in terms of notes. I kind of want like a new folder, just like articles, because like I think that's a whole different thing. And in this articles folder, I'll do like QAP, what? QAPO. VB. That might be good enough. I want to stop putting spaces in my titles and stuff. So QAPVB, and then I'll just... That's simple enough. Oops. And then just write a little, 2016 medium okay. There we go. And then, I just want to take down like the basics of notes, to be honest, and just make sure I have an understanding of what's going on with QAP. So yeah, this is tomorrow. hopefully in the morning. Rust for game dev. Okay. And then the afternoon. So here's the morning, here's the afternoon, here's my notes. Boom. I don't like this.